This is the A2 graphing linear inequalities example video. Okay, and it's very brief because graphing linear inequalities, as I just went over in the last video, follows the same process as graphing linear equations. Okay, so looking at this first linear inequality, this would be in slope-intercept form. So I'll go to my y-intercept, so plus 3. I'll make my first point. And my slope is 7 over 1. Okay, so I would go up 7 and over 1, up 7 and over 1. So I'm going to go to the left 1 and down 7. Okay, so I'm going to make a rough sketch here. I have a greater than or equal to sign, so it's going to be a solid line. Perfect. Okay, but I'm not done yet. So now I need to pick a test point. So I'll pick the point 0, 0. Okay, so I know this is x and this is y. So I have 0 is greater than or equal to 7 times 0 plus 3. So if I simplify, 0 is greater than or equal to 7 times 0 is 0, and then I have plus 3. So finally, I get 0 is greater than or equal to 3. Okay, so this is my point 0, 0 right here. So I picked a point on this side of the line, okay, and I plugged it into my linear inequality, and I got 0 is greater than or equal to 3. Well, 0 is not greater than or equal to 3. Okay, 0 is obviously less than 3. So, since my inequality is false, I'm going to shade the opposite side of the line of my point. So, if it were true, since 0, 0 is on this side, I would have shaded everything over here. But since it's false, I'm just going to hop over on this side of the line and shade everything over here. So I know any solution on this side of the line would satisfy this inequality. Okay. All right, so let's take a look at this one. This one would be in standard form. So I'm going to use the Jake's method for this one. Okay, so I know my slope equals negative a over b. Okay, so negative a, my a would be 1, my coefficient here, so I have negative 1 over negative 5. So my slope is 1 over 5. And my y-intercept, which is c over b, would be 15 over negative 5. My c being right here, and my b being right here. So 15 divided by negative 5 is negative 3. Okay, so y-intercept is negative 3, so I'll make my first point. And my slope is 1 over 5. So my rise is 1, and my run is 5. 1, 2, 3, 4. Okay, so here I have a less than sign. So I'll make this dotted line or this dashed line. Okay, not perfect by any means, but it'll do. So I'll do the same thing. I'll pick the point 0, 0. So 0, 0 being on this side. And again, you don't have to pick 0, 0. You can pick any point really in the coordinate plane. So as long as it's not on this dotted line, you could pick pretty much anything. Okay, so I plug in 0, 0, I get 0 minus 5 times 0 is less than 15. So 0 minus 0 is less than 15. So 0 minus 0 is 0. So I get 0 is less than 15. Okay, so the point I picked is on this side of the line. So it's 0 less than 15? Yes, it is. Okay, so the point that I picked satisfies my linear inequality. So since it satisfies my linear inequality, I'm going to shade the side of the line that my test point was on. So since my test point was 0, 0, my linear equality ended up being true. I'm going to shade this side of the line. Perfect. And now I'm done. And of course, it doesn't matter how much you shade as long as you've demonstrated that you understand which side of the line to shade and what kind of line you need, so dotted or solid, you will be all set.